Good afternoon, ladies and gentlemen. Hello. So the topic of our presentation is Vawtrak banking Trojan, a threat to banking ecosystem. And this is the agenda for today. We'll be discussing about the technical reversing of Vawtrak as well as the network information on Vawtrak. This is not audible. So my name is Raashid, Bhat. I work as a malware analyst for Blue.
And I'm Victor Acin. I work as well as a malware analyst, and I have a bit of a background on penetration testing. And well, I will hand over to Raashid, which will be actually performing the presentation for the reverse technical engineer of BotConf, and I will continue afterwards with the network insights.
So first, I'll be discussing about the technical reversing of Vawtrak version 2. And I'll be discussing about the campaign history and internals regarding the Trojan. So basically, Vawtrak is a banking Trojan. It's a banking Trojan. It performs man-in-the-middle in the browser. It's configurable. It's modular, and some of the banking Trojans are decentralized. They don't have one particular command and control server. Rather, they use proxies and low-level nodes to connect to the top-level nodes. And Vawtrak was it was known in the initial phase. It was known as NeverQuest, and it's among the top banking Trojans as of now. So, as I told you, it was known as NeverQuest before, and the earlier two versions were observed around November 2013 and then September 2015. So going back to the technical internals, it basically comes with a default packer on top of the other packers which criminals encrypt or pack it with. So the base packer, the default packer, the base buffer in the default packer is always LZMAT compressed. The earlier version used APLib, and the buffer, when it's decompressed, it reveals two executables, 32-bit as well as 64-bit, depending on what the system. Either one of them is executed. And apart from compression, it also uses XOR encoding. So after compression, XOR encoding is used to reveal the real executable, which is either 32-bit and 64-bit. Which is based on LCG algorithm. And to load it into another process, it uses a small PE loader to basically fix the imports and fix the region in the foreign process. Also, if the base executable is 32-bit and if the system is found out to be 64-bit, it uses Heaven's Gate technology to switch between 32-bit and 64-bit. Also, in the packer, the strings are encoded. And this is the representation of the LCG algorithm and the seeds it uses. Basically, this is how Vawtrak looks during the initial stage of infection. Out of the packed binary, we get the static configuration, which I'll be discussing next, and either a 32-bit or a 64-bit executable. And then either one of them is relocated in the main binary in a different memory region. So regarding this static configuration buffer, it's basically a buffer in the packed region of the binary, and it consists of certain parameters very important for the malware to run. For example, the command and control servers, the botnet configuration like project IDs, the version, in the earlier version it used DOR addresses and some cryptographic keys to verify the integrity of modules downloaded. The most important parameter among all of them is the botnet ID, which represents the unique bot in a Vawtrak network. And it's generated out from the combination of C drive volume ID and the adapter MAC address. So if we represent this static configuration in a textual form, this is what it looks like. So as you can see, it contains the same information as mentioned before, like botnet ID and whether it uses HTTPS or not, and some command and control servers over here. During the initial stage of infection, Vawtrak, the flow of the process is, it basically injects into explorer.enc and then followed by the injection in other processes or your browser like Internet Explorer or any other browsers which are currently running in your system. So that's the base flow of the infection. It follows all the processes, all the child processes in explorer.exe, and it makes communication to the command and control server from the running browser. Vawtrak also has a namespace generation system for storage. So for stuff like files and registry storage, it generates a namespace, unique namespace, again generated using the same algorithm, same LCG algorithm, but this time to identify a particular namespace, the seed is pushed to the algorithm. For example, let's say, to save the web inject configuration, it generates a namespace of 1, as you can see over the picture over there. So that namespace is generated and the web inject configuration is saved in that particular namespace registry. Also, it features a very interesting thing about the crashes and any debug logs that the malware produces during the runtime. All these logs are logged into namespace 3. And even if the application, just like any other your Windows application, if it crashes, then the crash log is sent back to the vendor. In the case of Vawtrak, it has a similar feature in which any crashes during the runtime of this malware, it's stored in a mini dump and it's sent back to command and control server. Also, while the malware is running, all the steps are logged in during the runtime. As you can see over in the picture over there, that's the start of the malware. At that time, it has injected into the shell and then followed by browser and then made some calls from different modules. So these all calls are, we guess, important for the development of the malware, as the authors have put them in the malware so that they can follow up and keep up with the development. Also, depending upon a switch in static configuration, it features a ring 3 rootkit. So if that switch is on, it basically hooks up create process internal API call, which is the base call from where the new processes are created. But that happens in explorer.exe, so all the new processes, they'll also be injected with the same payload, which is currently running in the Explorer. Vawtrak also has an IPC mechanism. So some calls which are received from command and control servers are supposed to be executed or are supposed to be executed in all different processes or some processes. So for that mechanism, for that purpose, it has an IPC mechanism to communicate between two different or many different instances of Vawtrak running in different processes. So for that purpose, it uses a global memory map file object, and that acts as a communication medium between different processes. And the base process from where all the calls grow is explorer.exe. So to represent the handler in C, this is how it would look like. And it consists of the process ID from which the call was made, and the opcode, and the parameters and the length of parameter. So all these opcodes are basically the API interface which the bot implements, the main module as well as the plugins, they all have opcodes or API interface, basically all the functions they export. Currently, around 41 opcodes are implemented in the main module, which includes some basic things like a connection to command and control server, restart of botnet, or for example, the opcode 25 represents retrieve a folder path, or opcode 2 represents save a web inject which was downloaded from command and control server. So even the plugins, they have opcodes. So each of them can, it's like a system all stacking all together, so that even the plugins can communicate with other plugins, or the main module can communicate to any other plugin. Even we can from command and control server, they can also send a particular opcode to a plugin and retrieve or store data. So now I'll be discussing about the C2 communication and encryption it uses. The base packet basically goes like this, and depending about the configuration in the static configuration buffer, it can be either HTTP or HTTPS. So the base data which is sent is botnet ID and some other parameters in the static configuration buffer, followed by the computer information, all the registered plugins in the system, and inject CRC32 word, which represents the older version of web inject, which was sent to that particular bot by command and control server. And this is how basically the command and control server identifies which of the plugins are currently running on the system and which are needed to be supplied, or even if there's an update in the botnet which is determined by the update and the build version. But this information is not sent plain text. It's RC4 encoded, and the key is a 32-byte random ID which is generated. And this key is again stored in the pattern so that the command and control server would be able to decode it. This key is stored in the PHP session ID cookie while sending it through HTTP request. So that is how basically a Vawtrak request looks like. And each of the subsequent requests would be random because this key is randomly generated. And the response which we get back from the command and control server after sending the initial packet is again compressed, and it's LCG encoded. Now this configuration which we get after decompressing and decoding the section, it has multiple sections, and for example, web inject is one of the section in that, and web injects are again, they are SBox, they are encoded using Xbox substitution algorithm. So if we have to represent the base packet in a C structure, that this is what it basically looks like, and it contains multiple sections, and that again is mentioned in the base packet. So Vawtrak also basically it comes in a form of a single binary, and then later on the plugins are downloaded from command and control server. So yeah, it is a modular Trojan, and each of the plugins, they provide an API interface in order to communicate with them or to expose the functionality. And currently it implements around 7 plugins, and the most commonly used ones are the Web Inject plugin, the Stealer plugin, the back connect, and the keylogger, and a file manager and a Stealer. But the most important one is the Web Inject plugin, because it's mostly used for banking fraud. So the data which is necessary for the Web Inject plugin to perform its task is the section 2, which is the Web Inject data. Again, it's Xbox encoded, and it consists of multiple sections, and each of the config value types have different meaning. For example, the config value type 3 has lists all the URLs which are supposed to be whose post data is supposed to be stolen. Or let's say the config value 2, if you visit those particular URLs, it would trigger out the video recording for those websites in your browser. So these are the various config value types for the web injects. And if we decode the web inject, it looks something like this, where it has a metadata included, which tells us from which section the particular entry is from, and the URL. An update was supplied on July 28, 2016, and this new version of the Vawtrak included a domain generation algorithm. It was there before as well, but it was present in the form of the Tor generation. But this time it included a full-fledged DGA-based domain generation system. So the domains are generated again using the same LCG algorithm and with an initial D word supplied to the domain generation algorithm. And also the number of domains to be generated is also supplied in the configuration. And it also implements SSL pinning for the verification of the domains in order to avoid or make takeover bit impossible. And this is the DGA algorithm if it's representing in Python. So the seed supplied from the static configuration makes it possible for the DGA to generate multiple domains. So that's it for the reversing side. Now I'll hand it over to Victor to talk about networking.
Thank you, Raashid. So I hope that the coffee has kicked in already and you're not half sleeping around here. Go ahead. Let's skip to the next slide. I'm fine if you want to sleep the whole presentation, but if you have to take something, I think that it should be this. What you can see here is basically the results of the investigation we carried in here from September to July, from September 2015 to July 2016. The first and most important fact that we found out is that there are at least two groups behind Vawtrak. We have the Vawtrak group, which is in charge of the actual infrastructure of Vawtrak, of stealing money from people. And then we have the Moscow Zapo group. The Moscow Zapo group, we named them ourselves based on one of the resources we found on one of their servers. This group is actually in charge of the distribution. After doing a bit of research, we found out that Moscow Zapo means something like drunken Russian. If there's any Russians in here, maybe they can correct me, but it means something similar to that. And as I said, they are in charge of distributing Vawtrak along all the Trojans. We detected up to 85,000 infections. And the 5 top targeted countries, based on the samples of Vawtrak that we retrieved, were US, Canada, UK, India, and France. The investigation also revealed that about 2.5 million credentials were stolen by the botnet, and approximately 82% infections worldwide target the US. Also, we identified basically about 4,000 IOCs that you can find in our community. I will talk about that later if I have time. These graphs here show basically the infections by operating system and by countries. As you can see, the US is the most affected country. And the other countries are practically, from the samples or the targets that we retrieved, aren't as affected as the US. About the operating systems, Windows 7 being the most used operating system is obviously the most affected. And one of the things that I found kind of interesting or noteworthy is that we detected about 2,000 infections on Windows servers. Now, this is a sample that is distributed using email campaigns. That means that either someone at home is using a Windows server to open their mail, to edit their documents, or we have some nasty system administrators using the company servers to browse their email. Now, I know what you're thinking. I don't know what this is, but this is really cool, right? No? No one? Come on, cheer up. No? Okay. Well, what you can see here is a snapshot of the infrastructure of Moscow's Depot and Vawtrak from September 2015 to July 2016. Yeah, it's a long exposure photograph. The red nodes represent the Vawtrak group infrastructure, and the Moscow Depot the Moscow Depot infrastructure is represented by the blue nodes. Now, as you can see in the picture, we have two differentiated infrastructures that are mostly connected using the green dots. These green dots are compromised servers and related samples that allowed us to link both groups. As I will explain later, Moscow Depot was, at the beginning at least, distributing Vawtrak using Pony. So we would find a compromised server which would hold a Vawtrak sample that is being downloaded by a Pony, and this Pony is reporting stolen credentials to another server, linking both servers and the distribution of Vawtrak between the two infrastructures. Besides Moscow Depot using the email distribution campaign, we also found two other sources of Vawtrak. Let's get first to Moscow Depot. The distribution method used by Moscow Depot is mostly email campaigns. These email campaigns had an attachment, a Word document that contained a Pony Trojan or Acin or H1N1 loaders, which afterwards deployed the Trojan. We have detected these ponies dropping Dyer, Vawtrak, and the other loaders deploying Pony, Vawtrak, SendSafe, an email gathering Trojan, and Andromeda, among others. We also found Vawtrak being distributed by another group, someone else at least, using exploit kits, but to a way lesser extent. Most of the distribution we detected was done by email campaigns. And also a third unknown group that was using H1N1, and that at least we couldn't connect to Moscow Depot. Now this next graphic shows the amount of infections of Vawtrak for every day we detected at least. As you can see, the distribution campaigns begin in 2015 in September, but the first infections, at least we didn't detect them until 2015 in October. Now there are two things that are very interesting in this timeline. First of all, at the end of 2015, we have a halt in the distribution. We actually couldn't figure out why this happened, but in March, April, in 2016, they stop again. Now, when they stopped the distribution in 2016, we started to see Vawtrak being distributed using dedicated loaders, being H1N1 and Janitor. As you can see afterwards, we have a spike of infections by Vawtrak, meaning that this change in the distribution method actually helped them to infect more machines. They had more control over what kind of samples they were distributing. I will explain this afterwards, but just to give you a couple of notes on this, Moscow Depot uses compromised servers to host the Vawtrak samples. Now, this is a problem because they can lose control of these compromised servers at any point. So when they were using Pony when you use Pony as a loader, it's basically a one-shot. You get infected with Pony, it downloads whatever malware, and then it stops executing after exfiltrating the credentials. But when they were using H1N1 and Janitor, what they could do is update the Trojans with new configurations pointing to new compromised servers, which grant them a more effective infection method. Whenever they detected that one of the compromised servers was taken down, they could just update the configuration for H1N1 and Janitor so it would point to another compromised server. So let's get into Moscow Depot. As I said, the main distribution method is an email. This email contains a Word document attached. The document attached has a macro that drops a pony. This pony obviously executes and sends the username and the stolen usernames and password to Moscow's depot, and afterwards acts as a loader and deploys the new Vawtrak Trojan, which communicates with the Vawtrak infrastructure. What you can see in here is basically the document that the Moscow's depot uses to distribute Vawtrak. It has instructions to activate the macros in case that the user doesn't have them active by default. And well, it's social engineering trick. What you can see here is the flow of execution of the macro. It first configures the macro to run at the beginning using one of these three functions, either auto open, or workbook open, so that when the user opens the document, the macro starts. At the end, these three functions end up in another function called tikatamba. This function configures three different paths in the temporal directory of the infected computer that point to an RTF file. RTF, you all know RTF, right? And afterwards, calls the function showMiddle. ShowMiddle is actually a wrapper for save as. What this function does is take advantage of the behavior of Microsoft Office when transforming documents. Turns out that docx can actually hold more information than RTF files. So when you save a docx document as an RTF file, what Office does is extract the files that are found inside the docx document and stores them in a temporal directory. So now what they have done is basically they extracted the loaders, either the pony or the H1N1 that was found in the document. And then they call the function Fractal, which is a wrapper for shell, in order to start the actual loader so it can begin to operate. Using bean walk on one of the documents, we can see that there is already a Microsoft executable PA. And with the next dump, we can see not only the MZ, but also the name of the PA, pm2.x. That's for the ponies. When they use ponies, the ponies have this name, pm2.x. This is the interface of one of the loaders, H1N1, and this is the interface for janitor. As you can see, you can modify the configuration of the Trojans so they can download the information from another server, even after they were deployed. Now, besides dropping Vawtrak, Moscow's depot was also dropping other Trojans. First of all, after switching, this was after switching to H1N1 and janitor. First of all, they started dropping a mailer Trojan, SendSafe, that they could use to spam other users. They also dropped an email gathering Trojan. So it was a sample that basically looked for PST files in order to extract contacts from the user, from the infected machine, sorry. Now, with these two Trojans, what Moscow's depot has is a synergy that allows them to infect more and more machines, the more machines they infect. So they would get into a machine, get more users or more targets in order to perform the spam campaigns, and then using the mailers, they will use those same machines to perform the spam campaigns. They kept dropping the pony Trojan because that was another source of revenue they had. At the beginning, when they were using pony as a loader, they were stealing credentials from the infected machines. So why would they stop stealing those credentials? Those credentials can give them access to FTP servers, they can give them access to SSH servers, or they can sell the credentials to access porn sites or Google in markets. And of course, they also dropped Vawtrak. The other distributions methods we detected, as I said previously, was, well, basically exploit kits, but I'm sure that all of you know how exploit kit works. Basically, the user enters an infected website. This infected website redirects the user to the site that actually has the malicious payload. The malicious payload is executed. The bad guys gain execution in the infected machine, and then, bam, deploy the Trojan, which communicates with the command and control server. Oops. And now for Vawtrak. We detected 3 different types of servers used by Vawtrak. We have command and control servers. The command and control servers manage the actions of the Trojan, provides configurations, and so on and so. The support servers contain the modules and updates for Vawtrak, and the automated transfer systems, or ATS, from now on, are the servers that allow the attackers to perform man-in-the-middle attacks, intercept communications, and modify the responses and the requests from the user to the targets. So I'll go really quick about this because Raashid already explained this to you. Basically, when communicating with the command and control server, Vawtrak sends the project ID, the bot ID, version number, and host-related information. When communicating with the support servers, they use this type of pattern. For modules, they use a hash of 32 characters that identifies the module that the Trojan has to download, well, the type of request that it has to perform to download the module. And for the updates, it uses a numeric ID. The modules, as Raashid told you already, are basically the web inject modules, a keylogger, a back connect module, and a data harvester module that's used to collect cookies, browsing history, certificates, and so on. Now, the interesting part is the pony module. Now, we have an infected machine with 2 ponies inside. One that was used and later deployed by Moscow Zapo, and another pony that was dropped by Vawtrak. So the credentials from the machine are stolen twice and sent to 2 different endpoints. So, Vawtrak infects the machine. How does begin to operate? What's the setup? Basically, when it infects the machine, it communicates with the command and control server, sends all the information we said previously. The command and control server responds with the Vawtrak version, the modules, and the configurations for the different modules and Vawtrak itself. Vawtrak then, if it has to update itself or download any modules, will talk with a support server to perform these actions, to update itself and to integrate the new modules that it has to download. And from this point on, it can begin to operate. We have detected Vawtrak using 2 different modes of operation. The first mode involves the ATS, and the second mode doesn't. So for the first mode, the ATS will perform a man-in-the-middle attack, and for the second mode, the web inject module will have the capabilities to modify the responses or to intercept or to steal the information that the Vawtrak group wants to steal from that target. Now for the ATS. We have 2 types of communication with an ATS. The first type is based on different get parameters. First, we have the command, then the target, the information of the bot, and a parameter that's used to exfiltrate more information. The second type of communication with the command and control server is the most common type, and it basically has the whole target site request as a resource, as you can see down here. See how inside fakes, in a request to the rsb.com site, it will just add the whole get request at the end, so that the ATS server knows which is the target and what information it has to collect or to modify. Oops. Yeah, sorry about that. So, this is a basic operation involving an ATS server. We have 4 components the web browser, we have the web inject modules, the ATS, and the targeted server. When the web browser attempts to communicate with the targeted server, the web inject module will detect this communication and, if needed, forward it to the ATS server. The ATS server will get this information, modify anything if it needs to. What kind of modification can an ATS server perform in a request, for example, to a bank? Well, if the request, for example, involves a transaction, it can change the destination account. It can change the name of the recipient. It can change many things. And then it will forward the information to the targeted bank. The targeted bank will then answer to the ATS server, which is performing a man in the middle. And again, if needed, the ATS server will perform any modifications it needs, like requesting additional information from the user, such as security code. And this information will then go back to the web inject module, which will then go back to the browser and will be displayed to the user. What you can see here is basically an example, a real-life example of how an ATS server is modifying a communication. In here, you can see how a user, well, it's trying to log in into RSB server with a browser that has been infected with Vawtrak. And in here, you can see the same browser with the debugging mode for JavaScript active. What the ATS server did in this case was basically inject JavaScript code used to log all the keystrokes of the user inside that web page so that it can steal the information, the login information for that user, which can be observed down in here. This information was being related to the ATS server as the user typed. Well, that's enough about ATS servers. Now, let's talk a bit about project IDs. As Raashid said, a project ID is a number that identifies the targets that Vawtrak has. While we were investigating these project IDs, we realized that some of them resulted in the same targets. So what you can see here inside those bubbles are all the project IDs we detected identifying the same type of target. We grouped them, and then we tried to guess what differences were between them. And so we were able to build this tree that you can see in here. We guessed that all the web injects come from a primitive web inject. We called it A. And from the web inject A hung the web injects B and C. We couldn't find these web injects on the wild, and we couldn't guess them from the ATS server. So we think that they were removed. But if I remember correctly, the web inject or the targets for the for the project ID, sorry, B, were targeting Europe, and the targets for the project ID C were targeting the United States. Now, from here, what we did was organize the project IDs based on the amount of targets they had, or small fixes in those targets. So, for example, project ID 1 would be older than project ID 10, based on that assumption, which will contain more targets or some fixes or some improvements over project ID 1, making project IDs 21, 20, 30, 13, and 10 the most advanced project or the newest project IDs in the time of the investigation. Well, you can download even more information about these two Trojans from our reports, Binary Insights and Network Insights of Vawtrak. And last but not least, I want to, if I have some time, I want to talk to you about an initiative of Blueleaf. It will be real quick because I'm not here to make commercial pitch. This is, we're just trying to create a community and have a user base that's basically researchers and security experts that want to collaborate and to share information between them. We're just trying to give a place for this to happen because we believe that this is important for the future of cyber threats, of cyber intelligence. That's it. So, questions and answers. No one? No one liked the presentation? I'm seeing some hands up there. It wasn't that bad.
In your paper, I believe you are drawing some conclusion between the Dia group and Vawtrak group. Can you elaborate a little bit more?
Well, we basically found, after we started studying the Moscow support group, that they were also distributing Dia samples. So they might be, we think that they might get to be, or that they were at some point an important player in malware distribution. Maybe we didn't realize before that there was one group, or maybe they started making mistakes afterwards, which allowed us to link all the command and control servers they had to the different samples. But they are related because we saw them actually distributing both Trojans.
Yeah, Renaud Tabary, I'm working for Lexi. Sorry for the voice.
Come again? Can you?
My name is Renaud Tabary, I'm working for Lexi. I have a question regarding the static configuration of Vawtrak. I had a quick look for a few months. And as you mentioned in the beginning, there are two types of URLs. You have the static command and control URLs and also a Tor URL that is used to update the URL list. And I thought, well, it's a nice way to have a look, to keep an eye on new CNC by just monitoring this Tor URL. But I had a look on 10 or 15 samples, and there was no Tor URL in neither of these samples. Did you manage to see use of these Tor URLs in the configs?
Talking about the Tor addresses?
Yep.
Yeah, but since its beginning, it didn't have, we didn't have much samples which had the Tor addresses. It was actually used as a backup plan. It's used as a backup plan in the Trojan. But as of now, it's they have moved to DGA, and they have also implemented another command, that's command number 41, to update the static configuration dynamically from the command and control server.
Okay, but did you see back then a use of this Tor URL in a config?
Well, back then it used certain Tor addresses, and it was supplying it. That was the earlier version, using an image. The data was it was present in an image, and
okay.
It was, yeah.
Okay, thank you. Just that knowledge.
Hello, my name is David. During the development of that transfer server, obviously the teams would make lots of mistakes with accounts. As they're testing it, they're changing account numbers, account name, stuff. Have you ever talked to the banks to look back at the records of the IP addresses used during that perpetration?
Actually, no. We haven't been in as much contact with the banking ecosystem as we would want of during the investigation. So we don't have that kind of feedback.
Hello, my name is Veronica. Quick question. I noticed that Vawtrak didn't change over time so much the CNC infrastructure, like not the domains, but the path and the URL types. What do you think is that usually malware, is kind of trying to change that to avoid detection?
Actually, one of the things that we did notice was that about domains, basically, was that they changed domains every 2 weeks or so. They changed domains really fast. In the report, I think we have all the references about this. They basically were switching domains constantly, just, I think, to avoid different kind of blacklistings and such. Why didn't they change the format or the way they perform these requests? I don't know, actually. I was thinking maybe this could be easily detected with some sort of IDS, like some snort or something, some rules like this. But taking into account that this isn't targeted at companies, this is targeted at users, at the end user, at the user that will try to connect to his bank to steal his information, he won't have an IDS at his home. So maybe antivirus companies could implement this kind of stuff, but they usually work with signatures. So did I answer your question? Thank you.